Hi, I'm James Patrick, Principal Cloud Architect at UK Government Defence at Oracle. I'll caveat this and say that this lunch and learn expresses my views and may not reflect those of Oracle. However, we are working on one mission, and that is to continuously support and improve the way that defence can operate effectively, safely, securely, and can continuously enhance the way that it delivers military effects. For me, this year, the focus is on design for decision. And this is all about the right tools in the right place to help you make the right decisions at the right time. And it's based around the concept that agility and security, if they're done right, enhance missions and improve the critical delivery of military effects. I think everyone knows Sun Tzu. The Art of War is a fascinating book and it's never really become dated. So, this quote here is where he says the quality of decision is like the well timed swoop of a falcon, which enables it to strike and destroy its victim. Therefore, the good fighter will be terrible in his onset and prompt in his decision. What that means is that good quality decisions are absolutely everything when you're trying to deploy an effect. You have to make the right decisions, and above all else, the good fighter has to make those decisions fast and effectively. So, design for decision has four key components. In order to design for a decision, you need to build around agility, security, mission, and effect. And as we go through this lunch and learn, what we're going to do is explore each of those four aspects in detail. So, if we start with agility, this is really quite simple. It's about deploying and integrating seamlessly from the core all the way to the tactical edge, so from the center to the field, so that you can have the right tools in the right place as and when you need them. If we look at what that looks like in real life and apply the Oracle product suite to it, we can see something glaring from the outset, and that's that all of this will work with the network of opportunity. So it's network agnostic. It could be the open internet, it could be a private operational network, it could be connectivity via satellite, it could be connectivity via a private LTE 5G network at the edge. It's network agnostic, but everything will seamlessly hang together within that connectivity. So at the core, at the center, we have three core options really. We have the public cloud, a fairly well trodden and well understood path. That's the cloud which runs in the public data centers, which is accessible to all. Some of the stuff is sharded, some of it can be dedicated, but it's there, it's one giant blob of hyperscale, if you like. As we move across, what you have is the sovereign cloud. So this is a dedicated data center, in Oracle's case, for government and defense use only, which is isolated, which is secured through its supply chain by security vetted personnel who are all locally based. There are procedures so that any developments in the public cloud have to go through a security procedure and code checks before they're released into it. And then we have a dedicated region, and this is a private cloud. This is your ability to have your own completely private, air gapped cloud region with full hyperscale capabilities where you need it. You see the little line there that says CDS. So cross-domain solutions are fairly well understood these days, but actually they're really potent because what they can enable you to do using a combination of software and hardware is enable safe, secure, two-way communication across a cloud estate, whether it be public, whether it be sovereign, whether it be dedicated, or all the way down to the edge. And actually, if we look at the simple sliding scale, you start with connected on the left and you move all the way over to isolated on the right. It's a really simple way of looking at it so you can see exactly where the middle ground is. Now, if we move down to the edge, you can see that actually we've got some extra capabilities. So we have compute cloud at customer or Exadata at customer, which is database centric. And if we look on the left, that's connected to your cloud tenancy. So the management plane goes in, your telemetry data, your billing data comes back out, and your operational data comes back out into your tenancy where it's managed. So the data on the device is secure and can't be viewed, but there's always telemetry movement between the two and constant continuous patching and updates because you have connectivity because it's over on the left. The same is true of the roving edge devices and the ultras. So these go from two-man carry all the way down to man portable or vehicle portable single box. So the red is ruggedized, but we'll talk more about that shortly. And again, at the connected, this works in the same way. They're ordered through your tenancy, they're managed through your tenancy, the telemetry and management data come from and go to your tenancy. As we move over to the isolated on the right, you have that same capability, but it can be air gapped, it can be operated through a cross domain solution or diode. The same is true of cloud at customer or the roving edge devices or the ultra. And the purpose of this is so that you can operate without hesitation. And what do I mean by that? Well, from the public cloud to the isolated tactical edge, it gives you the ability to unify your environments, your capabilities, and deliver that critical mission agility which can scale and flex in a way that is commensurate with the challenges of defense and security. And the truth is, agility empowers missions. So, technology to do that has to continue to flex, to be adaptable as the mission unfolds because missions aren't static, they change. So, you may start with one profile of technology and you may find that you rapidly need to deploy another. And that's what that estate that we just looked at before facilitates. It enables you to go from connected to isolated, from public to private, from core to edge, as you need to, and enables you to come back down again because missions aren't just a static shape. So at the strategic core, you have your bulk data processing, and this would be cloud, your mass analytics, your significant budgetary controls and FinOps. It's where you keep all of your process and policy and the core aspects of your people. As you move out towards the tactical edge with all of these things interoperating, this is where you're looking at assets, people, and the way that they're deployed, what they're doing, what's working, what's not working, data from sensors, a broad range of sensors, the combination of the actions of people with field doctrine, all coming back as reports which are being fed back into your center data and center analytics. And what that gives you is informed decisions at every point in the mission chain, from strategic to tactical. But what informed decisions give you, they enable you to make the right decisions about tech options and to continually right size your deployment. And this is about right sizing for impact. So, from self healing, large volume data storage, high concurrency, multiple user handling at the core in the cloud, you can move all the way across to powerful, lightweight software which is deployed at the edge for real time sensor analysis where it tactically matters. So, scale matters all the way across the estate. And the key is understanding the use cases. For example, a vehicle mounted ultra device needs to fit in limited space, and it could give you fast computer vision analysis on the move. A strategic command, however, they might need to ingest thousands of sensors, reports from hundreds of units, and they may need to make decisions based on all of that information, which shape the deployment of battle groups. So the edge scale is really simple. Cloud at Customer is rack scale, a red station is a container unit, a network red is a stack of two-man carry boxes, a red is a two-man carry box, and an ultra is that small device. So you can see the scale. But what you get with this, whether you're at the core or the edge, is a range of services. So at the core, that's obviously true hyperscale. So cloud compute, cloud storage, cloud networking, autonomous databases, analytics cloud, full fat machine learning and artificial intelligence. But it's interoperable with everything at the edge. So you get all of the APIs, you get the SDKs, you get artificial intelligence, for example, the Red is GPU enabled. Machine learning you can run on CPU, so even down to an ultra. You can do real-time replication with Golden Gate services, bringing everything back to your databases. You can run virtualized workloads, and you can run containerized workloads in a managed environment. And all the way across, and this is connected to isolated, there's this unified user experience because it's the same console, it's the same visual, it's the same UI, it's really intuitive, it's simple to use. And what that means is you're using a single investment in skills to be able to use all of these services. And what that also gives you is seamless security and assurance, because if your policy configuration and user management, identity and access controls are right here, they're going to filter through and be right here too. Now that's obviously a non-exhaustive list of services, but the thing that you get when you bang all of this together is you can unify your overheads into one easy to manage, easy to monitor situation. You get access to a full partner ecosystem for those applications that you may want to deploy. There's a rich marketplace of images which already exist, and that's everything in there from cross-domain solutions to virus scanning, and all of it can be served core to edge. So really, when we talk about Oracle, we're talking about empowering this agility. We're enabling the selection of the tech, the tools, and the partners for the mission to make the mission easier to deliver. So what we start with is the situation. What are the threats? Who are we facing? Where are we facing them? What are the resources, people, budget, technology, and what are the outcomes that we want? So what is it that we're looking to achieve? And we'll come more into the delivery of strategic and tactical effects shortly. This defines the mission. So what we actually have then is location, resources, and capability, the things that we need to do. As soon as we know that, we can make our tech selections. We can choose the right partners. We can choose the tools that they offer. We can make sure that we've got the suite of APIs and SDKs and even devices that we need. And this helps us select the core services and edge services so we can carefully formulate a budgeted, secure, effective technical deployment to support the mission. And what that gives us as we deploy is our operating capacity. It tells us how we need to do our networking and what the interoperation might look like. And also because we understand duration, how long is the mission intended to last for, how long is the tech intended to last for, and what happens when we finish, that keeps us updated and keeps everything flowing. And all of that goes into a continuous review cycle. So every step adds more information, enabling us to review what we're doing, why we're doing it, how we're doing it, how much it's costing, whether it's working, and that feeds back around the loop back to situation. So we get constant updating through this use of the agility approach. What I mean really is that you can define at pace. So by using this approach set out here, you can quickly define and then refine through that continuous review cycle a technical estate, and you can exert fine-grained resource controls and overhead stewardship through a single pane of glass. And this changes the shape of secure technology, I think, permanently, because it hasn't worked like this before. You need to go and get lots of different bits, then work out how they all interact. But actually, for us, we start with which cloud option, public, sovereign, or dedicated. Which hyperscale services, we select those through our console. Which partners, what cool tools are we looking to use? Are we taking them all the way to the edge? That tells us the shape of the edge services that we need to build, because we may need to know if we need GPU or not GPU. We need to know if it's going to a forward command or going in a vehicle. So what edge capabilities and marketplace images do we then need to deploy? Then we ask, what are our deployment constraints? So size, weight, power, noise, which tells us which edge compute we can use. So we come through this decision cycle at every step making good choices. And lastly, what connectivity model? Connected or isolated? At heart, we have our tenancy, we have our financial control, and we have our human overheads. So at core, we've got compute, storage, networking, platform services, marketplace images, and all of that can be pushed down to the edge devices. So we define at pace, and we can do it following a really simple, robust, easy to understand model that everyone can use and reuse. So what's the recipe for success with agility? Well, I see it as three things. The first is deploy at the speed of the mission. From public cloud to tactical edge, the success of it hinges on how fast you can act, not just how much you control. Control is easy, the ability to react and act is difficult, and a large portion of that problem is solved with this approach. Design once, adapt anywhere. So patterns and platforms that scale with purpose across teams, domains, and operational boundaries mean that you can apply one design and bring it to life wherever you need to bring it to life in a rational, deployable, sensible way. And the last thing, decision is the deliverable, the real deliverable. So technology only matters if it moves the mission forwards, and this agility means delivering informed action through data from the core to the edge without hesitation. We'll move on now to security. And I'm a cross-domain nerd, so I see this as relatively straightforward. What we're actually talking about and what we're looking for is cross-domain assurance from the strategic core to the tactical edge. That means that we need to know if we're operating at official, above official, that we can bring it all together seamlessly and have everything working safely. So if we go back to our first image, that one that started with the network of opportunity, and overlay some basic risk, in the mission sense, we can look at public cloud and connected, and we can say actually that's probably high risk because there's more direct internet access, there's more exposure to less secure networks, there's more shared infrastructure. We have things like follow the sun support on public cloud. There's persistent connectivity to the edge, so that management plane and the telemetry data. There's obviously, as a result of that, direct supply chain access and telemetry data return, which means you've got things pushing to and coming from. And you've also got DevOps capabilities to deploy to the device. So that means because of the connectivity, it's very easy to push things across those network boundaries. If we move into the sort of sovereign area, that's medium risk. We are talking about isolated data centers and networks that do have internet-facing capabilities as long as they're configured and safely assured. We do have those UK-based cleared staff providing support and managing environments. It does meet established assurance criteria up to official sensitive, so we're talking about things like JSP and GovAssure. These are obviously police-assured secure facilities, that's PASF, and there are a number of established workloads in the environment with trodden patterns. But it's still fundamentally a medium risk, just because there is connectivity. As we look at lower risk, so this is over as we're isolated, we've got air-gapped and completely private cloud region to start with. So that's just on its own. It's only available on customer networks. For example, if you've got a Catapan-bound network, it's behind those Catapans. There's no connectivity or actually just CDS only connectivity to the edge. So there needs to be a cross domain solution somewhere in there for it all to hang together. Otherwise, it's just isolated. The supply chain access is air gap too, and not even telemetry comes back. But what this does give you is a really, really good way of doing dev low, deploy high, because you could dev on your dedicated cloud and deploy high to your red or ultra boxes. And this follows really well established working practices at the high side. So really, security itself enables missions because technology has to be designed, implemented, and run in a way that it meets its threats. So if we look at what our adversaries are doing, and these could be organised crime groups, hostile states, foreign intelligence services, all the way down to hacktivists and individual chat GPT empowered 14-year-olds, they're doing three common things really. They're picking targets, they're selecting tactics, and they're using tech. So I know that we talk about attack surface a lot, but I think what we're actually talking about is the assurance surface of our systems. So we have within the assurance service our missions. Our missions comprise technology, processes, and people at heart. It really is that straightforward. So our adversaries are going to try and attack people, and they're going to try and attack process. This way you look at things like spear phishing and policy circumvention and fake calls to IT management centres for password resets. But they're also going to set their tech to work. And tech just follows quite a simple process, really, which is they attempt to get into networks, through networks into systems, through systems into storage, and that's how they attack technology, because they have to go through a number of steps in order to get to that crucial thing, which is data. So our security controls sit and they protect networks, systems, and storage, and fundamentally the data that runs all the way across that stack. So that's our assurance surface. If we look a little bit more closely at the actors themselves, we can put them in brackets and we can do some basic threat modeling about the kind of things that might be happening and what they may do. So if we look at the actors and start with the most serious, so hostile states and foreign intelligence services, we know that they are a threat because they're capable of sophisticated cyber and physical attacks. So they're going to go after devices and physical supply chain. They're going to go after networks and systems. They're going to go after personnel and credentials. They're going to go after libraries and dependencies to get into your code base. So the way that we approach dealing with that actor through our assurance surface is we say, actually, in that case, you're probably looking at dedicated cloud region and isolated edge devices. Really simple selection to meet the threat. We're looking at terror groups and organised crime. They're advanced cyber and physical attacks. So they might go after devices and physical supply chain. They definitely go after networks and systems, personnel and credentials, and libraries and dependencies. So what's our approach in response to that? Well, it's sovereign or dedicated clouds, depending on the nature of the actor, and isolated edge devices. And if we look at others, so moderate to advanced cyber attack capabilities only, they are going after networks and systems, but more predominantly personnel and credentials and libraries and dependencies, because as their skill levels and technology dip, it limits their options. So for those types of actors, we're looking at sovereign cloud, and actually connected edge devices will probably be sufficient. So our assurance surface, because we understand our threats, we can map which is the appropriate tech selection to operate with. Now, a key thing is presume breach to prevent breach. Movement across networks is a mainstay of sophisticated actors. They're highly adept at working around firewalls, so the steps across the network, what we need to do is aim to identify and prevent their lateral movement, and that's an essential component of any mission secure design, from a range of modern, efficient and easy to deploy cross-domain solutions which can enhance the technical estate, to out of the packet security features which are provided as standard. So what we actually want to do is shift to a presumed breach posture all the way from core to edge. And within the middle of that, there's a few things that you can do. Cross-domain solutions is a key one, so we have a lot of partners who do that, and marketplace images which are available for this too. So within your tenancy, your workload, you're going to have a DMZ, where you're going to have some CDS software. You may have two-way communication through a high assurance gateway, you may have one-way through a diode, but that will always come and back off on your edge device onto a CDS, and you can apply this between different types of cloud as well. It's a really basic process, quite a well-trodden path. But there are complementary security features as well. So OCI itself has taken steps to reduce threat proliferation between hosts because of the network visualization is implemented outside of the hypervisor. So even if you have a bad actor that escapes a VM and compromises the hypervisor, they won't be able to reconfigure the network virtualization, which limits their lateral movement to other hosts. Also, another example would be zero trust packet routing. So you set security attributes on resources in natural language policy, and that limits the network traffic based on the resources and the data services that are accessed. So lots of different options, from the deeply technical to the out of the packet and free to use, but presume breach to prevent breach. So what we're really saying here is that Oracle enables security by ensuring that configuration remains at best practice across mission estates. And we do this through a couple of simple different things. The first is continuous innovation. That runs all the time. The second is constant monitoring. So everything is logged, everything is auditable. But also within that, when we deploy, say for example, we use a standard infrastructure as code secure landing zone pattern, the other thing that we have is a constant benchmarking script which you can run. So that will give you any remediation or deviations from best practice. You can actually map those controls to any of your assurance controls, like NIST 800, for example, and that helps you build out continuous assurance reporting. So what you get is this continuous loop, innovation, assurance, and constant monitoring across your estate, and that keeps your configuration at best practice throughout. So what's the recipe for success for security? Well, I'm old school really. I do what my dad, who was a mechanic, taught me, which is measure twice, cut once. So we baseline our risk, we assess our exposure, we validate assumptions, and we do all of that before a single service gets deployed. Because security starts with situational clarity. What is it that we're doing? Where are we doing it? How big is the problem? We want to do secure by design every time. So we embed controls, not just compensations. And we assume compromise, we presume breach, and enforce least privilege, and we design for containment from day one. And lastly, really important, security is a process, not a pass or fail. It's not a point in time, it's not a one-off exam. You have to prove continued compliance with ongoing automation and human in the loop. What we're not doing is doing it once and then forgetting about it. What we want to be able to do is detect and remediate drift from those best practices in real time or near real time, because security and trust are not static, much in the same way that missions are not static. So on mission, we are going to adapt to changing strategy and tactics in order to be able to respond to challenges, and those challenges, as I've just said, they move, they shift. That's why we need the agility, and that's why we need our security to be fluid. Missions themselves, they start with a situation. It's 5WH, it's what, who, why, where, when, and how. And we use a probability yardstick to get to a point where we understand that situation, and we then apply that to our objectives. So what's our intent? What's the nature of the operation? Is it proportionate? Is it legal? What will the consequences be? That then helps us leap through to where we're looking at how we resource our intent and what we need to do. So we look at scale, visibility. Is this overt or covert? Location. Is it land, sea, air? Where is it? Which region? What's going on there? What do we know about it? What don't we know about it? Duration? How long could this take? Because we wouldn't want to fail to be prepared for something of a lengthy duration. Connectivity. Are we going to have connectivity? Are we going to be completely isolated? Is there anything that we can actually do there? And what we're looking at is delivering those doctrinal effects. So the selection really goes from prevent, stabilise, contain and deter to coerce, disrupt, defeat and destroy. That's military doctrine from government papers. Now, what happens is our objectives create data, our resources create data, and our effects create data. All of that should feed back into the decision loop, and that data should go back up to update our understanding of the situation so that the mission can be continuously improved as we go. So missions themselves, they target outcomes. So the purpose of the mission defines the operating parameters and in turn defines the technical choices. So we start basic, we have our mission parameters. We've got location, scale, connectivity, duration, portability and capability, the things that we actually need to do. As we move into tech selection, that tells us a lot of different things. So we understand how noisy can we be, how much power we're going to have access to, size and weight restrictions. Do we need to be carried? Can we be in a vehicle? Are we going to be at forward command? Operating temperature, information that comes directly from location. Capability defines whether we need GPU, CPU, memory, how many gigabytes of storage. Capability also tells us about systems, and systems tells us which partners we might need. And all of that feeds into our stack selection. All of that itself creates a data output which goes back into our decision loop and helps us to do two things. Number one is refine the mission continuously, and number two is deliver effect, because having the right systems and the right capabilities that meet the mission parameters will improve the delivery of effect. So if we just sort of lay this out a little bit, we've got HQ, we've got one of our forward commands in a contested environment, and then we've got a tactical unit in a disrupted environment. This is just a simple boxed way of looking at where we may be doing things. So we'll start with our tactical unit. We have sensor data that's coming in, adding to our battlefield intelligence, going into our local processing, those systems that we can deploy locally. That's going to give us operational decisions and effect delivery. What we're also going to do is take data from the effect delivery and feed those effect outcomes back to forward command, where that's going to inform lessons learned. That's going to give us aggregate battlefield intelligence through our local processing, albeit probably at a slightly higher scale, a compute cloud at customer, and that's going to give us operational decisions. Those decisions are going to feed down to the tactical units, but also back up to the center, where we're going to get lessons learned. We're going to get resupply decisions which go into our supply chain and back to forward command and back to tactical units. The supply chain also helps define the sensor data, because the assets will have different sensors that are going to inform our battlefield intelligence. Those lessons learned at the center, though, they tell us things on top. What training do we need to look at in future? What strategic decisions do we need to take short, medium, long term to inform the commands? And also the effect outcomes and those strategic decisions both play into a much broader point, which is they tell us how and when to invest in what kinds of research and development and procurement to solve the problems that we face from the contested through to disrupted environments. So all of that data is in constant motion. And if we overlay that, we can start to think about the types of capability that we can use to deliver on those problems. So at HQ, we want hyperscale cloud services, compute and storage, AI and machine learning, autonomous self-patching databases. We're probably always connected, in fact, almost certainly always connected. We have high volume analytics, granular security and FinOps, software as a service and platform as a service applications and enterprise level capabilities. At the Ford command, whether we're on Compute Cloud Customer, an edge station, or a stack of roving edge devices, we might need AI and machine learning. Plug and play on any available network, virtual and containerized workloads, the capability to operate connected or disconnected, because we may have intermittent connectivity or none at all, granular security and FinOps again, and we're going to want some volume compute and storage. And as we come down to that disrupted environment, the tactical unit, we can actually see those roving edge devices and ultras. And that's going to give us AI and / or machine learning, depending which one we have, a more limited amount of compute and storage, which we need to use intelligently with the right systems. Plug and play, connected and disconnected, virtualized and containerized workloads, and still that granular security and FinOps. So that's a very practical overlay of mission tech in the mission context. And what all this means is that Oracle delivers to purpose. If a mission is based on purpose, then Oracle delivers to the purpose, ensuring that the right tech is in the right place at the right time. And if we look at headquarters and look at it almost in terms of user stories, so to deliver this mission, headquarters might need to deploy rack scale capability to forward commands and edge devices to tactical units so that they can run on partner systems. But also, they need to continually analyze any returning data to ensure that the strategic decision loop is data driven and that in real time they're capturing those lessons learned to inform broader defense decisions. So the kind of technologies that we're talking about there are secure landing zones, self-healing, self-patching databases, real-time analytics, and those enterprise-grade applications. If we move to the Ford command, the user story might look like we can't rely on stable 24/7 networking, but we still need to be able to capture, analyze, and utilize data and systems and feed back to HQ whenever possible. So they have largely stable power, and they can accommodate larger items of equipment which can be locally networked. So we're looking at those Compute Cloud Customer larger scale devices, and that gives us secure tenancies and compartments, compute and GPU, block file and object storage, and all of those APIs, SDKs, and console management that are common all the way across. And as we go down to the tactical edge, the user story might be that we often need to operate completely disconnected, or actually just have denied networking. But you need to be able to use partner systems and analyze data on the fly. So they need devices which are man or vehicle portable with lower noise profiles, which can adapt to a range of rugged operating environments and temperatures. So that's where you get these secure devices that are man or vehicle portable, CPU and or GPU, with all those APIs and virtual and containerized applications. And crucially, again, it's that one skill set, that single skill set drives all the way from headquarters to the tactical edge. So if we just have a look at a very basic type of architecture, we can see our assurance surface, we can see our mission, we can see our lessons learned on the left, we can see our effect delivery on the right, and our decision loop constantly flows across. So HQ might have autonomous database, some Apex applications, analytics, and those end users. In our contested environment with our local storage, you might have some virtual machines, container engine for Kubernetes, some AI and ML, and that set of users. And in the disrupted environment, you can have that local storage, those virtual machines or containers, and that set of users, all working seamlessly together to keep that decision loop live, to capture those lessons learned, to deliver the effects when they need to be delivered, and all within that single assurance surface, which is safe and secure. If we overlay that again, what we can actually see is all of the different components feeding in different directions. So we have lessons learned captured at the center, we have lessons learned captured from the forward commands, we have lessons learned captured direct from those tactical units. All of that is informing value strategy, so that's R&D investment, human resourcing, procurement and partnerships, but also informing mission strategy, so that's supply chain management, doctrine, utility and success or failure factors. And we're also getting feedback from the effect delivery too. So the effect results are coming straight back to tactical units. They can decide what to do on the fly. Back to the forward commands, they can take a slightly longer term view. And also back to the centre, feeding back into that mission strategy. What's happening with decision is we are using all of this information at the centre to take decisions to deliver long-range effects based on centralised analysis. We can scale that down to the forward command and take it on deliver mid-range effect based on forward command analysis. And we can use our short to mid-range effect at the tactical level by using what's being analysed at the tactical edge. So what we're talking about is bringing everything together and rationalising it in a highly interactive and effective way, which keeps everything working smoothly, not just over the short term, but planning for the long term too. So the recipe for success for missions is understand the decision outcomes that drive the mission. So start with the intent, not the tools. Get clarity on the desired effects. And that guides every operational and technical choice through the mission. Build to the boundaries of reality constraints. So power, policy, bandwidth, budget. It says police there, it should say policy. Excuse the typo. Work with what's available. Winning comes from designing within limits, not ignoring them. Flex as the mission develops. So this is about adapting the structure, scale and flow without breaking the principle. So maintain alignment as the conditions shift and the decisions evolve. Flex your tech estate to the mission. Lastly, we're going to talk about effect. So what we're aiming to do through all of this is to inform decisions to deliver immediate or enduring outcomes. We go back to that military effect from doctrine, and actually we can see we've got two key things on either side. We've got decision effects and data effects. So decision effects use what we have, what else we need, what we've tried, what worked, what other options to feed into the military effects that we can deliver. That feeds out to data effects, so we understand what we used, what it did, what we expected, what happened, was it successful. And that means that we've got constant flow of impact coming back to our decisions and expectation coming back to our decisions, so we can better understand what it is that we're doing, what is working or not working. Effects deliver effects. Analysis delivers decisions, decisions deliver effects, effects deliver data, data delivers analysis. It's a constant cycle. So analysis establishes where we are currently, what's the current situation, what are the available options, what have we done before that's worked, what resources and assets do we actually have that could be used, and what are the probabilities of them delivering the outcomes that we want based on the data that we understand and know. So decisions after the analysis, this is where we're deciding where to place and position our resources and assets. We're formulating short and long-term plans, initiating any immediate actions and evolving as new analysis emerges, because it's a loop. So effects are delivering our resources, assets, our tactics, all bringing them to our identified targets, intending to produce outcomes which resolve that situation. And through that we get data. It's generated by the delivery of those effects, and it feeds back into analysis, drives the decision loop. So we're always going analysis, decision, effect, data, analysis, decision, effect, data, all the way through, facilitated by good technology. And what we might have is, if we look at data analytics over at the center, at the core, we're going to have structured data, unstructured data, streams and events, data science and dashboards. That's going to push forward our SITREP to our decision systems and push forward our targeting to our effect systems. Over here in our decision systems, we might have summarization, we might have expert systems, we might have AI or ML augmented systems. All of those decision systems build towards triggers, which are our effect systems, kinetic and non-kinetic. Those systems generate data, visuals, sounds, reports, other outputs. And that's where our data collection comes in, where we may have summarization systems, AI and ML augmented systems, data integration tools. All of that is pushing our outcomes back to our data analytics so we can run through the loop again. Our decision systems are returning actions so we can put them back through the loop and come to it again. But actually, if you look at this logically, where you have a highly capable technical estate that can go with you from core to the edge, you can run that model at your tactical units, at your forward commands, at HQ, and across the whole piece, from your home to your contested environments to your disrupted environments, having that high quality, continuous data collection, decisioning, effect delivery, analytics, all together working independently and seamlessly in unison. And this is the thing, Oracle delivers effects from that data collection and the analysis to the decision tools, and we deliver that across the mission. It could be databases, transaction processing, warehouses, catalogs, analytics, integration tools, real-time replication, AI and ML, all the way through to hyperscale compute, storage, networking, deployable with or without connectivity, running virtual and container workloads from any supplier. We've got those edge devices, with or without GPU, they're rugged, they're portable, we have that single skill set to use it all, the one ring that binds them if you want to go all Lord of the Rings with it. And it's network agnostic, secure by design, we are trusted globally, we started in defence and we are built for defence. And that takes us back to where we started. Our network of opportunity and our core public, sovereign and dedicated clouds, connected and isolated, compute cloud at customer, roving edge devices and ultras, all enabling you to operate without hesitation from public cloud to the isolated tactical edge. So effect the recipe for success. It's build capability to understand the effect delivered. What we want to do and what we do is equip missions with meaningful data. We want to be able to utilize that data from the start. We don't just want to prove performance, we want to also measure impact so that we can make better decisions. We want to learn the lessons from that captured data, analysing intended and unintended consequences to get real insight from the deltas too. And we want to predict future outcomes to design better missions. So we're going to use that evidence to feed simulation, iteration, forecasting. Every mission should inform the next, as operational advantage is cumulative. The more you have, the more you compact it and compound it, the stronger it will be. And that's it. That was Design for Decision, my presentation about how we use agility, security, mission and effect together and design better systems that work for defence. As Sun Tzu said, victorious warriors win first and then go to war, while defeated warriors go to war first and then seek to win. Victorious warriors start with a good design that's mission-centric, that's mission-focused, that uses technology the right way, and that is the art of war.